me again, Jeff, and we're going to look at problem 13.5 from Briggs and Cochran's calculus book. Now, in this problem, I wanted to actually evaluate an integral. So this problem asks, what is the iterated integral? What is the answer to the iterated integral from these limits of x squared y dx dy? So if we remember, these limits 0 to 2 correspond to the inner limits correspond to the inner variable, and likewise the outer to the outer. So we can write it this way if it helps us to think of it better, and we can also draw a little picture if that helps us. But the point is, we don't need to. We can just evaluate it. But we just have to remember the order. We're working from inner to outer. Okay? So for the first one, we're going to have integral from 1 to 3. Okay? And we're just going to evaluate this inner integral. So we have x cubed over 3 evaluated from x equals 0 to x equals 2. And we could just write 0 to 2 there if we wanted. We could draw a bar here. You know, there's different ways to write it. This is one way. And don't forget to bring your dy along for the ride, because we still have this and don't forget to add your y there. Okay, carry it along for the ride, what needs to be carried along for the ride. And so we have boosted and divided to get our integral. So we boosted the x power 2 to 3, and we're holding y constant, and we're dividing by what we boosted, or our new exponent that we have here. And so now we can evaluate this, bring it along for the ride, and we have plugging 2 in for x, we have 2 to the third power. Well, that's 2 times 2 is 4, 4 times 2 is 8, so that's 8 thirds minus, plugging 0 in, we get 0, y dy. Okay? Now, we can pull out constants from the integrand. So we have 8 thirds integral from 1 to 2 of y dy. Okay, now it's something that we're familiar with from Calculus 1. We can just boost and divide y, so this is y to the first, so it's going to be y squared over 2. So this is equal to 8 thirds, and we can evaluate the integral y squared over 2, evaluated from y equals 1 to y equals 2. And now we can plug in 2. See, I wrote it down wrong. I'm sorry. This should be 1 to 3. And so we have y equals 1 to y equals 3. And now we can evaluate this. We have 8 thirds times, evaluating, we have 3 squared is 9. So 9 halves minus, plugging 1 in, we have 1 half. 1 squared is still 1. Okay, that's a tilted 2. So 9 halves minus 1 half is 8 halves, which is 4, and we have 32 over 3. So equals 32 over 3. Now, just to prove to you that it works both ways, let's really quickly evaluate it with the opposite. So instead of that way, let's go integral from 0 to 2, integral from 1 to 3 of x squared y dy dx now. So now we're going to hold x constant and integrate with respect to y first. So we bring our integral for x along for the ride, and we can actually evaluate, can't we? We can say x squared, bringing that along for the ride, y squared divided by 2, evaluated from 1 to 3. Okay, and now we plug in 3, and we get integral from 0 to 2, we have x squared. Plugging 3 in, we have 9/2 minus 1/2. Okay, we can actually evaluate this. This is 4x squared. Oh, and don't forget your dx here. Now we can evaluate from 0 to 2 x squared and bring the 4. This is 9 minus 1 is 8 over 2 is 4. We can bring it out of the integrand. So we're integrating from 0 to 2 x squared dx. This is equal to 4 times, and we evaluated boost and divide by our new exponent. And we are going to evaluate from 0 to 2. So 2 cubed is 8, 8 over 3. So 4 times 8 over 3 is equal to 32 over 3. And we see that it checks out both ways. So there you have it. I hope this problem has helped you a little bit. Thank you for watching.